Hi, I'm Norm Abram. Welcome to the new Yankee Workshop. Today we revisit a two-part program we did here several years ago. It involves so many steps that we decided to divide it into two programs. And even at that, it was a challenge to fit everything in. The project was to build a simple backyard greenhouse, suitable for raising and displaying plants that require some protection from the cold. We would need a level site, big enough for a small 6-foot by 8-foot greenhouse, that got 6 hours or more of sunlight in the spring and fall, and near enough to a water and electric supply for easy tending. We probably wouldn't worry about heating it in the coldest days of winter, and that was before heating oil and gas became so prohibitively expensive. All right, and finally the other gable end. Instead of using real glass for glazing, we would substitute a clear double-wall polycarbonate that many professional growers use today to save energy. Such material and related accessories would be available on the internet or, in our case, from a greenhouse supply company. Instead of using aluminum framing, which is used for most commercial houses, we would make our frame out of wood and machine it with our woodworking tools. Instead of a concrete floor for a foundation, we would use a system of 8x8 pressure-treated sills laying on a bed of crushed gravel, which had the advantage of making the greenhouse portable if it ever needed to be moved. Now, once these panels are set in place, it's going to give us quite a surface that the wind can catch and want to lift the building. So I'm going to secure it with these long pieces of number 4 rebar. One in each corner should do the job. Here's how we got started. Greenhouse Part 1. That's next, right here in the new Yankee Workshop. Now our greenhouse is going to be about 6 feet wide, 8 feet long, and 9 feet to the peak of the roof. And if you'd like to build one, a measured drawing will be available with the materials list, and you'll hear more about that before the program ends. The foundation for the greenhouse is going to be made up of these 6x6 pressure-treated pine timbers, much like I used on the storage shed. I'm going to build a perimeter frame with half-lap joints at the corners. So I've laid out the material that has to be removed to make the half-lap. I'll first make cuts with the circular saw, and then I'll finish them off with the hand saw. But before we use any power tools, let's take a moment to talk about shop safety. Be sure to read, understand, and follow all the safety rules that come with your power tools. Knowing how to use your power tools properly will greatly reduce the risk of personal injury. And remember this, there is no more important safety rule than to wear these safety glasses. And this will finish it off. I've set aside the timbers for the foundation, and now I'm at the other end of the greenhouse, right up at the peak of the roof. I'm using redwood for the frame, and these 2x4s, which will be the rafters, also need a half-lap joint. Now to make the half-lap, I've set up a stacked dado head cutter in my radial arm saw, and I've installed this stop block to give me the shoulder or the length of the half-lap. Now here's a tip. If you set the stop at an angle, you reduce the possibility of sawdust building up against the stop that would give you a false cut on your shoulder. The next operation on these rafters is to make a groove to hold the glazing. Now here's a sample of the glazing. It's a polycarbonate, 2 thicknesses with webs between, and it's quite clear. You can see right through it. And it's very strong. It adds some insulation value, and I'm just going to set it into a groove in the side of the rafter. On the gable ends, I'll need grooves on the inside. For all the other frames, grooves on both sides of the rafter. To To make the groove, I'm using my 5/16 stacked dado head setup for a depth of 3/8 of an inch. Let's look at our sample rafters again. Because of the half lap, I'm going to have to make a groove across the grain so that the glazing can make it all the way to the peak. I'll make that cross cut using my miter gauge. The next step is to make a groove along the bottom of all the rafters. On the gable end rafters, it will receive the glazing and a collar tie. On the intermediate frames, just for the collar tie. The next step is to make a notch at the bottom of each rafter, and this will fit over a ledger board that ties all the frames together. So I've established a fence at my bandsaw, and the first thing I want to do is make the rip cut. To complete each notch, I'm using my miter gauge set at a 45-degree angle. The studs on which the rafters will sit and the sill plates will be 2x3s. So I'm taking 2x6s, ripping them in half, cleaning up the sawn edge at the joiner. The next operation is to cut the top of each stud to this shape. The angled portion picks up the bottom of the rafter. The flat portion will pick up a ledger, which is going to tie everything together. I've laid out the cut. The first thing I do is make the square cut at the radial arm. I'll complete the cut at the bandsaw. My miter gauge is set at the same angle that I used on the rafters, 45 degrees. The next operation is to make 4 studs with a very simple notch that will pick up a redwood ledger board later. I'll make the notch using the radial arm for the crosscut, the bandsaw for the rip. Well, now I'm back at the table saw making grooves in all the studs, just as I did with the rafters. Let me show you what that's all about. There are 3 different layouts for the grooves, depending on what the stud is being used for. There are 6 intermediate studs. There's a groove along the edge for bracing, and a groove on each side for the glazing. At the corners, there are double studs. This is the gable stud, and it has a groove for the glazing and the braces. The doubler just has a groove for the glazing. Let's finish them up. Here I'm dry fitting a pair of the gable end rafters together, and I want to show you the blocks we're going to make next. Each will add structural integrity to the piece. A little block at the top with tenons that fit into the bottom of the rafters. A collar tie, which will keep the rafters from spreading apart, again with a tenon, and grooves for the glazing. And down at the bottom of each rafter, there's this knee brace, which has tenons that fit into the groove of the rafter and into the groove of the stud. I'm set up to make the knee braces first. I've attached this auxiliary fence to my radial arm saw, just using a couple screws. I've tipped the blade or turned the saw to 25 degrees, and I'm ready to make the first cut. I've removed the auxiliary fence, turned the saw to 45 degrees. Now I place the cut edge against the fence and make the second cut. While the radial arm is still turned to 45 degrees, I'll cut the 5 collar ties and the 5 top blocks to size. Now I'm ready to start forming the tenons. So I've set up my stacked dado head cutter for maximum width, installed a sacrificial fence, and I'm using my miter gauge to guide each piece through. Now I've turned my miter gauge to 45 degrees on the other side of 0, and I'll make a pass on the other face. Now with the miter gauge set to 90 degrees, I can make the second pass on the ridge block. Now the knee braces. With the dado head raised, I'm going to make one pass on one side of each tenon. The result will be an offset tenon, which is what I want. Now with the dado head reduced to the size I need for the glazing, I'll make the appropriate grooves in all the blocks or collar ties. Here I'm drilling some holes in the collar ties of the gable ends, and they will be useful to relieve some condensation problems that may happen in the panels. Here's the glazing for our greenhouse. It comes in 4-foot by 12-foot or 16-foot sheets. We picked it up at our greenhouse supply company, and it comes with a film on each side to protect it while we're working with it. It's double wall, which gives it insulating value, and the side that has the blue film on it has to face out because it has a UV protector, which will extend the life of the polycarbonate, yet it lets all the light through. It's fairly easy to cut using a fine-tooth blade. I'm using a plywood blade in my circular saw. The first piece I want to cut is this triangle, which is for the top of the gable end. Now I'm ready to glaze one of the gable ends. And the first thing I have to do is seal the top edges of the glazing. The manufacturer supplies a self-sticking aluminum tape for that purpose. The tape that I use along the bottom edge is a fabric tape. It'll keep bugs and debris out, yet it will let any condensation that builds up in the panel escape. Now I'm ready to assemble one of the gable ends. And I'm going to use this moisture-cured glue, which calls for wetting one of the surfaces and applying the glue to the other. To secure the joint while the glue dries, I'm just using a few 1 1/4 inch brads. Now I'm going to apply glue to the tenon of the ridge block, and we'll set that in place. Now a clamp to just pull it tightly into place, and I'll pin it with a couple more brads. Now, make sure the blue film is facing out and slip the glazing into place. All right, that's partway in. Now let's try to slip the collar tie in place. And I think a clamp would be useful to help pull the collar tie into place. Now it's starting to go. Now this is the other gable end, and this time I used the collar tie to drive the glazing into place before I glued it. That way I made sure that it was set exactly where I wanted it. It seems to go a little bit easier. You learn something with every one of these that you do. Yeah, it's 5'10" 3/8", notch to notch. That's just right. Now we can pin it. All right. Now while that gable end dries, The next step is to attach the knee braces to the individual studs. And for that, once again, the moisture-cured glue, applying it to one surface, which is dry, and just wetting the mating surface. The next step is to work on the sill plates for the gable end. I've laid out the location of each stud, and I want to make a notch so that the stud will sit into the sill plate. The best way to do that is with the radial arm and the stacked dado head cutter. With the same setup, I'm going to make notches in the sill plates for the side walls to receive the studs. This next piece of 2x4 becomes a purlin, and I've laid it out for some notches where it will intersect the midspan of the rafters. It'll help support the glass and stabilize the roof. With my saw blade tipped to 45 degrees, I'm going to rip the top edge of this 2x4. It'll become the top plate which fits into the notches on those rafters. And those pieces will need a groove for the glazing. A couple of holes in the sill plate at each glazing panel will relieve any condensation problems. Well, now we're finally ready for the first major assembly. And the first thing I want to do is attach the end studs of the gable wall to the truss assembly. So some more of that moisture-cured glue on the tenons, put it together and tack it with some brads. Now I'm just going to take a sample of my top ledger and make sure that that's going to fit in here okay before I tack it. That is good. I'm going to put a clamp on this, and perhaps it won't come apart when I put the glazing in. I've installed the vent tape along the bottom edge and the foil tape along the top edge, just as I did before. Now let's see if we can get it to fit in these slots. Now I got to get the other side set in the groove. Now this is one of the studs that'll form the door opening, and that gets glued in place and it slips over the glazing. And now I'm ready to pin this side. And now the sill plate. This is going to be a little tricky because I've got to slip it over the studs and into the glazing. Okay, that's pretty good. Now I'm going to secure these joints with some screws. Well, I think we'll let this set until the glue dries. Then I'll build the other gable end that has a window in it. Well, before I left last night, I was able to complete the other gable using the same techniques that I used on this one. Now I'm starting on the side walls. The sill plate for the side wall is the same as the gable in that it has a groove for the glass and weep holes to let any condensation out. There are shallow dados for the intermediate studs, which have the knee braces that we made earlier. The end stud has no knee brace, but it has a notch to receive the top plate. They're assembled with 2.5-inch screws. Now the end stud has to overhang the plate. The gable end will slip in underneath it. Now for the glazing, just slide it into the groove, being sure that the blue film faces out. Now a little bit more of our high-tech glue to secure the joint between the stud and the top plate. Okay, we'll just slip this onto the glazing. Now to keep it square, I think I'll just tack a batten on it. Well, before long, we're going to need the foundation for our greenhouse, so I'm getting started today by setting the timbers on a setting bed, just making sure that they're level. Now, each corner is joined together with 2 lag screws. I like to clamp the corner together, that way it stays in position as I do the drilling. I'm going to start with a 1.5-inch spade bit to make a counterbore to recess the head. Now I'm going to switch to a 3/8 auger bit to drill a pilot hole for the lag screw. Now there's one more hole in each corner. This time I'm using a 1/2-inch bit and I want to go all the way through. Now once these panels are set in place, it's going to give us quite a surface that the wind can catch and want to lift the building. So I'm going to secure it with these long pieces of number 4 rebar. One in each corner should do the job. Let's get the rest of the panels and start the assembly. This is an important step. I'm snapping chalk lines to show me the inside of the sill plates. When I designed the greenhouse, I made it so the wall will overhang the foundation just enough to let the water drain out of those weep holes if there's any condensation in the glazing. All right, we'll set this gable first, bring it to the line, and there's not much to secure this, just some 2.5-inch screws. Could you imagine how heavy these panels would be if they were double-wall glass? This acrylic makes them nice and light. Now this corner will just slip together, and we'll secure it to the sill with some more screws. All right, and finally the other gable end. That's good. Okay, we got a good start on our backyard greenhouse. Now next time we'll build the roof, make a window and a door, and we even have a way to make roof vents that'll allow the heat to escape from the greenhouse. And we'll build some benches. That's next time right here on the New Yankee Workshop. Hi, I'm Norm Abram. Welcome to the New Yankee Workshop. Today we complete our look back at the greenhouse project we did several years ago. After it was constructed, the greenhouse sat just outside the shop, right in this location. Sadly, it was never used for plants. And eventually we needed some space for the storage shed, which you see here now. The original greenhouse was disassembled and trucked to a new location, where I'm happy to report it is used by a passionate gardener every day, from early spring to late fall. It has sheltered thousands of seedlings, hundreds of cuttings, dozens of display plants, and can be reliably counted on to produce the first tomato of summer every year. The owner wouldn't part with it for all the tea in China. Of course, sometimes he wishes that it was much, much bigger. But then again, I don't know a keen gardener who doesn't long for more space to satisfy his plant growing addiction. Now, let's return to part 2 of the greenhouse program to see the final assembly and the rest of the accessories like doors, venting, windows, and the benches. That's next, right here in the New Yankee Workshop. Before I can install the remaining trusses that hold the sidewalls, form the roof, and hold the glazing, I'm making a notch right at the peak to receive the ridge cap because I want it to be flush with the top of the rafter and to hold down the glazing. Now, if you choose to build the greenhouse, a plan will be available with all these details and a materials list. You'll hear more about that before the program ends. Now let's build that ridge cap. With one side of the ridge cap clamped in my side vise to hold it, I'll be able to set the other side on top. Now, the whole idea of a ridge cap is to cover the roofing materials where they meet at the peak. And in order to have each side of the ridge cap equal, it's necessary to rip one piece so that it's narrower than the other by the thickness of the board. Now, I'm going to secure these pieces together with some screws. But before we use any power tools, let's take a moment to talk about shop safety. Be sure to read, understand, and follow all the safety rules that come with your power tools. Knowing how to use your power tools properly will greatly reduce the risk of personal injury. And remember this, there is no more important safety rule than to wear these safety glasses. Now, a bead of caulking along the inside edge is not going to hurt. Sequence is very important at this point of the assembly. I'm stacking in the 3 trusses on one end of the greenhouse, and now I'm going to take the purlins and slide them into the upper triangle. Otherwise, I'm never going to be able to get them in. We'll just let them set on the side for now. Then I can take each truss and work them down the line for the final installation. Now, if this greenhouse was going to stay here permanently, I would apply some glue to this joint. But because we want to move it later, we're going to assemble it dry and secure everything with some screws. Okay, that takes care of number 1. Let's slide in the second one. Well, now the third one. You can imagine what kind of mess I might have gotten into if I hadn't put these purlins up here first. A screw through a pre-drilled hole in the top of each truss secures it to the top plate. Now the next step is to slip the purlins into place, notches slide in over the rafters, and secure those with some screws. With the purlins secure, I can now install the ridge cap, and that'll get a screw on each side of each rafter. Even on a cool day, this greenhouse is going to get pretty hot inside. So I'm going to install 2 roof vents, one right through the opening I'm standing in now, and one over on this side. In order to do that, I'm going to have to add a couple pieces on top of the purlin to secure the fixed glazing down below. I've just taken a piece of 1x stock and ripped it at a 45-degree angle. And this will be a stop to secure the glazing at the eave line. The next step is to make a rabbet at the square edge to receive the glazing. This is one of 2 cuts I'll need to make for a groove that will allow any condensation that builds up in the roof panels to escape. With a guide block temporarily secured to my fence, which is cut at a 45-degree angle, I'm able to hold the strip in the right position to complete the weep holes. The last operation on this piece is to make a notch at each rafter tail location. Well, now I'm ready for the roof panels. We're using some more of that polycarbonate double wall panel. The manufacturer supplies a foil tape to cover the ends at the top so nothing can get inside the voids. We'll just slide it in the grooves that I made in the rafters, making sure that the blue film faces the outside because that's where the UV protector is. Now at the bottom of each piece we have a different situation. I install a fabric tape supplied by the manufacturer, keeps the dirt out, yet it lets the moisture escape so that it can fall through those weep holes we made in the edge strip. Notice that I've installed a spacer block at the top of the purlin, and that's to hold the panel away from the purlin, because if moisture builds up on the inside, we want it to go right by, not drip on you. Okay, that's the last panel on this side. Now for the eave strip. It will take a little fussing to get it into the exact position, but once it's there, I'll secure it with a few screws. There's a couple more things I have to do to complete these panels. The first is to pry each panel up about 1/16 of an inch from the rabbet so that any water that comes out of the panel can run down the rabbet and they'll go out through the weep holes. The second thing is to secure the panel. Wood holds it down on 3 sides. I'm afraid if I don't put something at the bottom it's going to buckle, but I have to have the water run off. So I've selected the thinnest material I could find, this thin aluminum, and I'm going to secure these strips with a few screws. Of course, the screws that I'm using are rust resistant. Now, some water could run underneath the aluminum channel, so I'm just running a small bead of caulking, a special caulking supplied by the manufacturer to be used with these polycarbonates. Now all we have to do is peel off the film. Well, that takes care of everything on the outside of the roof. There's one more thing to do on the inside. I have to install a block under the ridge to keep the glazing from sagging. The top edge of the blocks that I'm using at the ridge have been beveled at 45 degrees on each side. They just slip between the trusses against the glazing and are secured in place with a couple screws. Now here are all the parts for the various pieces. This set here is the rail and stile set for the door. This is 2 rail and stile sets for the roof windows, and this is a set for the window on the gable end. The first thing I'm doing is running a groove which will receive the glazing and tenons to join the pieces together. I'm using my stack dado head cutter, a little bit wider than 5/16 of an inch. I'll run the piece through, turn it around, run the other edge, and that assures me that the groove is centered. Now here's a window frame, and I'm just dry fitting it together. You can see that I've formed a tenon on the rail that fits into the groove of the style. Now, the roof windows will be made the same way. And the door. And let's review how you make those tenons. I've set up a gauge block, set the height of the saw so that it cuts just to the groove, and set the distance to make the shoulder cut on the tenon, which I make first by using my miter gauge to guide the piece through. Now I'll just slide the fence out of the way, take the piece that I just made the shoulder cuts on, and eyeball the blade, raising it until it meets the cut I just made. Now to make the cheek cuts on the tenon, I'm going to use my tenoning jig, which rides in the miter slot, and it has a clamp to hold the piece safely as I run it through. Here's one of the frames for the roof vents, dry fitted together. And the glazing is going to sit in the side pieces and in the top, but down here at the bottom, I don't want to have the water hang up. I want it to roll off. So I'm going to have to remove the outer portion of the rail. This is the center rail for the door. Condensation could form here. These weep holes should help. The glazing is next, and to cut this polycarbonate, I've installed my fine-tooth laminate cutting saw. Just as I did with the panels on the greenhouse, I want to seal the top edge of each panel with this foil tape. Now I found that if I use a small piece of dowel to press it into place, it eliminates any wrinkles which make it difficult to slide into the slot. And at the bottom of every panel, the fabric tape that breathes. And now for some more of our high-tech glue. I apply the glue to one surface, I've pre-moistened the other surface, and you just slip them together. This is a moisture-cured product, so it takes moisture from the air or the moisture I've added to the joint to cure. And you'll be surprised it will foam up out of the joints, but you can grind it off easily after it cures. With the rails glued to one side of the door, I can slip in my glazing panels. Depending on the humidity and the temperature, the open time for this glue is between 30 minutes and 4 hours. And after I put it together, I should keep it clamped for about 24 hours. Okay, that's good. Before I quit tonight, I want to glue up the window and the two roof vents, and I'll see you back here first thing tomorrow. I'm getting started this morning drilling the through holes in the aluminum which will secure the glazing in our roof windows. The first hole is a 5/32 through hole. Next, I'll countersink for the screw head. Just as we did with the roof panels, I'm securing the piece with some rust-resistant screws. This is the outside of the roof vent, and this is the bottom, so the water can flow right off. My roof vents are going to pivot on some butt hinges, and I'm going to use an automatic opener, so I want hinges that are not going to stick. So I've chosen hot-dip galvanized hinges with brass pins. I'm going to make sure I keep these lubricated. I'm mortising the hinge into the roof window. And the mortise is a little bit deeper than I need because I'm going to surface mount the hinge to the ridge, and I want to have as small a gap as possible between the window and the rafters so that the building is watertight. Now here is how I set up for each hinge. I hold it on the edge, align it, take a sharp utility knife, and score the outline of the hinge. I'm going to remove the majority of material for the mortise with my router and a 1/2-inch mortising bit, and then I'll clean up the rest with a good sharp chisel. This redwood is so soft, it Cuts easily with a good sharp chisel. More rust-resistant screws to secure the hinge to the unit. Find it a little bit easier if I take the hinges apart and then attach the leaf to the ridge. Now all I have to do is slide the unit in and secure it with the pins. Okay, let's put the other one in. We picked up the opener for our roof vent at our greenhouse supply center. Inside this tube, there's a heat-sensitive material. As the greenhouse heats up, it pushes this end of the tube out, and there's plenty of leverage in this arm to open the window through the rod. As the temperature in the greenhouse cools down, it automatically closes. The installation is pretty simple. I've attached the clip to the window. The mechanism will be attached to the purlin with a couple screws, and then we'll hook it all together with the rod. That's all there is to it. The temperature variation will do the rest. Here's the sash for our awning window, assembled the same way as the door and our roof windows. I've already mortised the top rail for the hinges that will pivot the window. Now I've set up my stacked dado head cutter with a sacrificial strip to make a rabbet along each edge. I'll show you what those are for in a minute. At the window opening, the hinges are simply applied to the underside of the frame. These thin strips are going to slide into the slots that are in the studs, and they will act as stops against which the rabbet will rest. Okay, now I can set the sash in place, slip the hinges together, and drive the pins. Give it a try. Okay, that works good. Now all I got to do is find out a way to hold it open and hold it closed. There's one more piece I want to apply to the window here in the shop. It's this sill piece, cut at a 10-degree angle, and a saw curve placed in the front edge to let the water drip away. Now I'm going to install it so it overhangs the sash about a ½ inch, and that'll allow it to close against the frame. A bead of caulking on the inside edge, and I'll attach it with a few screws. One more piece out here at the greenhouse, a piece that's going to act like a drip cap to shed the water away from the window. The angle that it's cut at is 10 degrees. All right, well that should keep most of the elements out. Now we're ready to hang the door. And I suppose most woodworkers would mortise for the hinges just like I did on the window and the roof vents, but I happen to have a door mortising jig. Now the jig will accept all different size doors and hinges. I've set it up today for a 3-inch hinge and a 6/6 door. The first thing to do is to slide the jig up to the top of the door and set the gap I want between the door and the frame. In this case, 1/8 of an inch. Then, by tapping down on these pins, I can secure the jig to the door. Now there are 3 jigs, one for each hinge, connected by bars. To remove the material for the mortise, I'm using a collar supplied by the manufacturer and a 5/8 inch mortising bit. The collar just rides around inside the jig. It works great. Now I just pop the jig off, and the last thing that I have to do to the mortises is square up the corners because the router leaves a rounded corner. Using this square chisel makes fast work out of squaring up each corner. Now we'll take the same jig and mortise the frame out at the greenhouse. Now's a good time to remove the sill plate from the doorway. Well, there's the jig set up on the door, and you can clearly see the advantage. Without moving anything, I know that all my mortises are going to line up. Now I just route them out the same way. The next thing I want to do is bevel the latch edge of the door so that as it closes, it won't hit the frame. It's something you do to all doors. In the old days, they used to do it with jack planes. Today, we use power tools. I'm going to use my power plane, which is set up with a single cutter. Also has a guide fence, which I've tipped in 5 degrees to give me the bevel I want. A couple passes along the edge should take care of it. Okay, let's see how it fits. Slide it in over the hinge. That jig never makes a mistake. Now let's see if it clears okay. That's good. Now it's time to build some benches. For the top of our bench, I'm going to use some 1x4 cedar. I've cut the pieces so that they'll overhang the front by about 3/4 of an inch. I'm going to leave plenty of gap between the boards. So I've made a 5/8 inch spacer, and that will give me plenty of room for the drainage when I water the plants. To install the benches, I've set up a few temporary support sticks. Now I just got to slide the bench into position, then I'll crawl underneath and attach it to the studs with some screws. Here I have a storm and screen door latch, and that should be plenty for what we need here. These 1-inch wide strips of cedar will act as stops for the door. I'm going to let them hang in the opening a 1/2 inch, and I'll secure them with some 4-penny finish nails. Hey, we're ready for the plants. That was a good project. Now next time we're going to build a project I've been wanting to do for a long time. One of the fireplaces in my new house needs a mantle. So next time we'll build one right here in the New Yankee workshop.